Hi, this is Mohammad Abdul Ghafoor. I am a computer science grad from Texas A&M University Commerce, and today I'll be presenting a presentation on BlackFeather, a framework for background noise forensics for the core digital forensics. Let me begin with the outline. So we'll be going through introduction, then the background noise and the uses for the from the paper, the related work already done, and the proposed contribution from this paper, and the framework used, and the results, and finally we'll see the conclusion. Let me give you a brief introduction about this. So basically, with this paper, the background noise is being used from the whole noise which is collected as an audio evidence. The background noise is separated from the actual audio noise from with the speaker and the background noise that is present in the particular audio. And the extracted background noise is then used to find the specific location or environment where it has been recorded or the evidence must have been taken place. So basically, with the BlackFeather, it's actually a pipeline of multiple networks, which is designed for processing at each step, and it consists of many neural networks, specialized architectures. So what is a background noise? As you can see over here, background noise can be anything like a person speaking on a phone and the traffic sounds coming from the back can be a background noise, or a construction worker working on some specific site and the sound coming because of it can also be a background noise. We can imagine a situation where a crime is happening and it has been recorded on a phone. And to narrow down the specific location, we can hear a construction work going on at the back. And with this, the investigator can know that where in the city there's some work going on. And then with this, the location can be narrowed down to a particular area or place. As we can see over here, background noise. This is a specific noise that is being as an audio evidence for the investigator. This is then separated between a human speech, what any human or someone is communicating in the audio, and the background noise, what the background or something, the noise that had been coming within the area. So a specific audio set is divided between a human speech and a background noise. These are all the examples of the background noises that we can hear in an audio visit, like a train approaching or a bird, or due to the weather, a rain or a thunder, something like that. Can all this can be background noises. So basically, what is the use of this project, or what is the use of and what are the uses that has come through the paper? So firstly, because of this, we get to know about the environment wherever a crime scene is happening, or at least we can narrow it down to some specific place or specific location. With this paper, we are getting a high accuracy results after running through different models, after running through different training data. So this can be very useful in predicting the area or location. It can help for the forensic investigation uh, to speed up the process of investigating by narrowing down some spaces to places. And it also helps in gaining more clues, more evidence, finding actual places, finding a nearby more evidence. And it can also help in us confirming about some alibis or disapproving them. So the related work done on this. Not much work has been done regarding the background noise for the crime investigation, but the papers that have worked on it are the following. So the first one is the background sound classification in speech audio segments. It has worked on the classification of background noise, but it was not able to analyze the multiple noises that were coming. It was not able to extract or separate the multiple noise uh, that were in the part as the audio evidence. The next one was digital audio forensics, microphone and environment classification using deep learning. Through this, they were recording devices of multiple environment and classes. But with this paper, human speech or human interaction was not able to be found. The next one is digital audio forensics using background noise. In this paper, special extraction was used. The method was used, but background noise classification was unable to be performed, and the recording or originality was authenticated with it. The next one is background or foreground classification. It has an accuracy range of 80 to 95% it was able to reach there, but background noise for all the places were not able to be classified through this paper or the model. So what have we done? What are the contribution done by the paper for this? So the first one is with this experiment, we were able to reach use the raw background noise to to separate the actual background noise with the human speech and find actual location with where that background noise could link to. It had helped the forensics team to create a better forensic scheme during the investigation. And multiple noises or the background noise that have been overlapped with human interactions or human voices were able to be separated, and a better results were able to reach because of this. And multiple speakers can also be present in any audio evidence, where they can be 2 to 5 or any number of people, and all the voices can get interlinked or overlapped, and these voices were able to be separated by using the model, and multiple good results were achieved at different stages. Mixed ES50 dataset was used for the classification over here, and a better results were achieved after this. So the framework used for this, basically this framework consists of two processes. The first one being noise processing, and the next one being noise profile analysis, location processing. We'll look into each of them. So the first one being noise processing, it consists of three parts. The background noise extraction was the first thing done when the background noise was extracted from the whole audio set, and then the second process was the background noise was separated. Whatever the background noise was achieved was separated into different different subsections which they can belong into, and then this background noise were classified into different schemes, different things. So for all this process, deep neural network was used, which has proven a very effective for them. And from this, the next stage, which was noise profile analysis, was done. And as we can see from the picture over here, there's a mixed audio. It was then encoded, and the background noise was separated and then decoded into different human speech, and the background noise separated. This is basically a blueprint of the framework. We can see the training phase and evaluation phase over here, where there are two noises after extraction, few human speech, and a background noise, which are in which different methods are used, and both the noises are being separated and extracted to gain useful information at the end. And even in the evaluation phase, we can see the background noise has been extracted and classified, and so that a better data can be collected, which can be used by forensic teams. These are the two method calculations that were used in the paper for calculating the accuracy. And then moving on to the next step, which is noise profile analysis. So basically in this, the Bayesian model was used, which is good for more conditional probabilities with K models. And in this particular paper, the data set used had 1,721 pairs of data, out of which 1376 were training data and 345 were testing data pairs. And the overall accuracy that it had given is 95.8%. There were a total of 37 classification, and all were distinct, all were unique. And they were at last, there were total of 112 kinds of noises in there. So the results achieved with the model. We have used the GPU of NVIDIA P5000 with Windows PC. The dataset, as I said earlier, for the audio set which was used was from the corpus library speech, and the dataset name was ESC50, mix ESC50. With this model, they were like K voices with each of 10 seconds, which were interpreted and extracted from a whole set of 50 to get voices of from among 50,000. The voices that were collected were cross mixed to generate 1,225 K squared voices in total. From among this, 80% was used for the training purpose and 20% were used for the testing purpose, with the K being as phi. The rate that we have achieved at the final as the learning rate was 1e minus 4. As you can see over here, we got the results as after human speech and after background noise with training and without training, there were different results that were achieved. Even with the denoiser and with original distance for the this one is for the combined audio set, and this is for our data set combined ES50. So the results that we have achieved in comparison with the method that are already in existence, the classic method, we have proven that the accuracy have shown significant increase, and we are able to achieve pure classified accuracy through this. The results showed here were like for the background noise after testing, the DNA classification, which is the deep neural network classification, gave an accuracy of 94.85%. And in separated background noise with testing through deep neural network, we got an accuracy of 86.74, which in comparison to the existing models or the already present model is slightly higher, as the already existing model have only 82.67% accuracy. Then again, in comparison with the classic model for separated background noise with fine tuning to get the best results, in deep neural network classification, we got an accuracy of 91.32%, as in the classic method, which is only 87.80%. So as so this percentage differences we can see, we were able to achieve a great increase in the accuracies, and in all the process and all till we get a better accuracy and results, the time overhead was also maintained. I like to conclude with few points over here. The background noise forensics mainly has removed the big challenge that was it has moved its process into an automation work instead of the manual work, which was very expensive, which was very calculated and difficult to handle. And this work has been shifted into an automation to the systematic framework. And with this framework, not only we were able to make it much more easier, but also a good amount of good accuracy levels were reached, and a better information like at the exact location, at least nearby area could where we were able to locate. So this framework, it was designed, experimented, constructed, and the whole process was done very carefully, and with this good results we were able to achieve. So the two main things that it was able to overcome was the first thing was the manual work, and next thing was that good results to get the exact location and more information from the background noise, which we weren't able to get from the existing models. Background noise was not much used, and it was just shredded, and only the human speech was being used as an evidence. But with this, we can use background noise also as part of an evidence and to narrow down a specific location to use the whole data sets and gain more insights from any part of evidence. So this is all part of the project, and this is how BlackFeather has helped the forensic investigator to gain more knowledge and location, exact location, and to use the whole audio set evidence more precisely and get an better accurate results, which was narrowed down a location a part of it. So thank you, everyone.